In this assessment, we're asked to make the molecule oct-4-ine 3-ol using a combination of an acetylide ion with an aldehyde. Let's draw oct-4-ine-ol first. We'll start by drawing the alkyne. It's going to be an 8-carbon molecule where the 4-carbon is going to be the alkyne. So we'll have this one here. We'll put in 1, 2, 3, counting left to right. 1, 2, 3, 4. 5, 6, 7, 8. So there is our oct-4-ine. Turns out, regardless whether we were numbering left to right, we would get the same name. And then we're going to put the hydroxyl group at the 3 position. We're not going to worry about defining the stereochemistry because our synthesis is going to make a racemic mixture anyway. How would we do that? Well, the question said that we needed to use an acetylide ion. And so what that implies is we're going to be making this bond here between the carbon of the alkyne and the carbon here of what will be an aldehyde. So let's go ahead and work backwards. The last step for all of these reactions is going to be an acid quench. So at some point, we're going to have made this alkoxide intermediate like this. And now this alkoxide intermediate is, again, if we number our carbons, is going to be formed by forming a bond between carbon 3 and 4. Specifically, we're going to have nucleophilic 4. We'll draw it as the acetylide ion. Nucleophilic carbon 4 attack the aldehyde at carbon 3. We're not so worried about mechanism with this problem, but if we were to draw a mechanism, we would show this lone pair attacking this carbon and pushing these electrons. All that remains is how we make the acetylide ion, and we're going to use old chemistry for that, chemistry previously studied, reaction of the terminal alkyne with the strong base sodium amide. This is how we would synthesize oct-4-ine 3-ol.